Hi, I'm Kian, and today I want to show you how to find the area under the curve and above the x-axis of a function on a given interval. So you have this function y equal to x squared, and you want to find the area under the curve from the interval 0 to 1. So the first thing we want to do is to form rectangles under the curve. And for this, for finding the area of the rectangle, we obviously need the height of the rectangle and the width of the rectangle. The width of the rectangle is calculated by b minus a over n, where b and a are parts of the interval. In this case, 0 is a and 1 is b. So 1 minus 0 over n. 1 over n is our delta x, which is our width. And our height is just 2 because we have a coefficient of 2. 2 times k, which is a value, times 1 over n times the delta x, and then squared because it's the second power. So our height is 2 times k over n just squared. And now the next step is to just simplify this. So if we simplify this, what we get is that, so if we simplify this part, this is k squared over n squared, so we get 2 k squared over n squared. And now if we multiply it by this, by the delta x, we get 2 k squared, and then over n cubed. Now, we're not done, because now for our next step, we have to evaluate the sum from k equals 1 to n of 2k squared over n cubed. So I go to the next page. So we should evaluate the sum from from k equals 1 to n of this expression, which is 2k squared over n cubed. And now because our variable is k, our sum is based on k, we can take out 1 over n cubed outside of, actually 2 over n cubed outside of the sum. So what we get is that if we take it outside of the sum, we get 2 over n cubed. And now what we are left of is a famous sum, is a sum from k equals 1 to n of k squared, which has a famous value, which I make a video to prove it. But for now, the value is just n times n plus 1 times 2n plus 1 over 6. And when we simplify it, we get 2 n cubed plus 3n squared plus 3n squared plus n, and all over 6. Now, we can see that this 2 cancels, we get 1, and this becomes 3. And now for our last step, we all know we should take the limit as n approaches infinity. So for our last step, to find the area under the curve, the actual value, we should evaluate the limit as n, this is limit, as n approaches infinity of this expression, which is 2n cubed plus 3n squared plus n and all over 3n squared. And now, what we are left of is a famous limit, because now we're working with the highest powers. We know that the highest powers are 3, so we're working just with the coefficients of n cubed. And we can just simplify it. 2n cubed over 3n cubed is just 2/3. So we can conclude that the area under the curve and above the x-axis of y equal to x squared on the interval from 0 to 1 is just 2/3. And another way that you can check your answer is to evaluate the integral. It's an integrate 2x squared and dx, 2x squared dx, evaluated. So we can evaluate the integral from 0 to 1. And now, using the power rule, integral of 2x squared is just 2/3 times x cubed, evaluated from 0 to 1. And if we put 1, we get 2/3 minus 0. This is just 2/3. And we know that our answer is correct. So the integral was the easy step, but we used the Riemann sum to solve it. Thanks for watching. Please subscribe to my channel.